Alright, so this is the second part of our video because we had to split up the first one. So we're starting here with number 9. Number 9, we're going to go ahead and, because we have negative 15 here in the y, we want to go ahead and have a positive 15 down here, so we're going to go ahead and find something to multiply the bottom equation by. So we're going to go ahead and multiply the bottom equation by negative 3. So we carry over the top. We have negative 7x minus 15y equals 22. And here we have negative 6x because it's negative 3 times 2x. We're going to distribute it. Plus 15y, and that's going to equal negative 9. This way we can go ahead and eliminate the y's. We have negative 13x equals 13, so x equals negative 1. We're going to take this negative 1, we're going to plug it back into either one of the equations. We'll pick the bottom, 2x minus 5 times what y is equal to, which is negative 1 equals 3. So we have 2x plus 6 equals 3, and I've done something wrong. Hang on. What did I do wrong? So we have the negative 1. Oh, I plugged it in for y. Hang on. Alright, so we have, I'm going to plug it in for x. We have 2 times negative 1 minus 5y equals 3. So we have negative 2 minus 5y equals 3. When I subtract the 2 from both, or add the 2 from both sides, we get negative 5y equals 5, therefore y equals negative 1. So my solution is the ordered pair, negative 1, negative 1. Moving on to number 10. Number 10 is solving each system by substitution. We're going to start here with number 10, which is going to be the easiest way to go ahead and solve by substitution because both of the equations are already solved for y. So we're going to take what y is equal to here and plug it back into the other equations. We have 4x plus 22 equals 3x plus 15. We're going to solve for x, subtract 3x from both sides. We'll combine two steps here, subtract 22 from both sides. So we have 4x minus 3x, which is just x. This cancels out, and we have 15 minus 22, which is negative 7. I'm going to take this negative 7 here, and I'm going to plug it back into either one of the equations. I'll pick the top. We have y equals 3 times negative 7 plus 15. So y equals negative 21 plus 15. Therefore, y equals negative 6. So my solution, negative 7, negative 6. Now, number 11, even easier than the other one. Because y is already solved here, y equals 5x, I'm going to go ahead and plug y into the other equation. So we have 6x minus 4 times what y is equal to, which is 5x, equals 14. So we have 6x minus 20x equals 14. So we have negative 14x equals 14, therefore x equals negative 1. I'm going to take what x is equal to, I'm going to plug it back into the first equation since that's going to be the easiest to solve for y. And we have 5 times negative 1, which is just negative 5. So my ordered pair, negative 1, negative 5. Okay? Alright, so our word problems. Word problems. We have to go ahead and keep all of our lines together. So Julia and Nadiba, I guess, are selling fruit for a school fundraiser. Customers can buy small boxes of grapefruit and large boxes of grapefruit. Keywords here, small boxes of grapefruit and large boxes of grapefruit. Okay? So Julia sold 7 boxes of grapefruit and 1 large box of grapefruit for a total of $48. Now again, that right there tells me one line of my system of equations. Julia sold 7 small boxes plus 1 large box for a total of $48. Okay? And then we have Adiba, who sold 6 small boxes plus 11 large boxes for a total of $244. So let's go ahead and just assign variables here for a second. We're going to assign the variable, let's say x represents small and y represents large. So we define that as x equals small boxes and y equals large boxes. So if we rewrite this system, we have 7x plus 1y equals 48. And then we have 6x plus 11y equals 244. Now we solve this. The easiest way to go ahead and solve this, more than likely, is going to end up being using elimination. I can multiply this top by negative 11 because that gives me a negative 11 here that I'm looking for to cancel out my y's. So if I rewrite this top equation, I have negative 77x minus, because I'm distributing this negative x to the 1y, minus 11y equals, we have 48 times 11, 48 times 11 equals 528. So we have negative 528. All right. We carry down the bottom system, same way, 6x plus 11y equals 244. So here we have negative 71x, my y's cancel out, and negative 528 plus 244 is negative 274. So we're going to divide both sides by negative 71. And we get 274 divided by 71 will give me an answer that I'm not looking for. So I did that wrong. Let's see here. What did I do wrong here? Don't do it. Making the correction, this is actually 284. All right, so we have now 284 divided by 71 will give me 4. So x equals 4. Now that I know that x equals 4, I can plug this back into one of the original equations. Use this one right here. So we have 7 times what x is equal to, which is 4, plus y equals 48. So we have 28 plus y equals 48. Subtract the 28 from both sides, and y equals 20. So again, you have to summarize the solution here. The solution is, since x represents the number of small boxes, right up here, then we have 4 small boxes, and we have 20 large boxes. So that's what the y represents. Okay? For sake of time, I'm going to skip the next one. We're going to go over here to graphing inequalities. Where's that page at? Okay. All right, so we have x is greater than or equal to 3. X equals 3 is a vertical line that goes through 3. Because it's a non-strict inequality, it's a solid line vertically going through x equals 3, and because it's greater than, we're going to shade to the right. Okay, next one. Go ahead and put this into slope-intercept form by subtracting x from both sides. We have y is greater than negative x plus 5. So I'm going to start with my y-intercept, which is 5. My slope is down 1 over 1 for a -1 slope. It's strict, so we have a dotted line. And because it's greater than, we're shading above it. Not even paying attention. Losing the opportunity. All right, so next one, we have a system of inequalities. So this is the one we need to go ahead and find the common shaded area. For the first one, we're going to start here at the y-intercept, which is 2. My slope is up 2 over 3. It's strict, so I have a dotted line. And because it's greater than or less than, we're shading below it. All right, the next one, we have a y-intercept of -2. My slope is -1, so it's down 1 over 1. So resuming, we're going to go ahead, because this is a strict inequality, we have a solid line. And because it is less than or equal to, we are shading below. So we can see here that because this line right here is shaded below and this line right here is shaded below, we're establishing that common solution, which is going to be right here. All right, the next one, again, first one, we start with the y-intercept of -2. My slope is 1 over 2, so I'm up 1 over 2. It's strict, so we have a dotted line. And because it's less than, we're shading below. All right, the next one, we have a y-intercept of +2, a slope of 5 over 2. Well, if I go up 1, up 2, up 3, up 4, up 5, I'm off the graph. So I can rise 5 and go to the right 2, or I can go down 5 and to the left 2. Same thing. So I'm going to go down 5, 1, 2, 3, 4, 5, and to the left 2. This one is not strict, so it's going to be a solid line. All right? And because it is greater than, we're shading above it. So we can see here that we have a very, very small solution set that exists right down here at the bottom. All right, we'll just do one more of these last two. We're going to go ahead and put both of them in slope-intercept form. Let's just go ahead and do 19. Let's take the first equation, put it in slope-intercept form, which is, we're going to subtract the x from both sides. So we have 2y is greater than -x plus 4. Divide everything by 2. And so we have y is greater than -1 over 2x plus 2. The next one, we have 5x plus 2y less than -4. Subtract the 5x from both sides. And so we have 2y less than -5x minus 4. Divide the 2. And so we have y is less than -5 over 2x minus 2. All right, so we go ahead and graph both of these. The first one, we start with the y-intercept of 2. We're going down 1 over 2. It is strict, so it's a dotted line. And because it's greater than, we're shading above it. All right, for the second one, y-intercept of -2. This one says we go down 5 and over 2. So if we go down 5 and to the right 2, or I can go up 5 and to the left 2. I'm going to go up 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, and then we're going to the left 2. Again, dotted line because it's strict. And this is less than, so we're shading below it. And again, we have a very small solution set that exists right here.